The platform must meet 3 fundamental criteria. They must be standardized, they must be high performance, and they must be high available. Standardization ensures interoperability and simplifies the management. All hardware and software must comply with documented specifications as well as reference architectures. High performance ensures that workloads are processed under normal as well as peak conditions. High availability means the system is architected to remain operational even when single components will fail. The combination allows predictable and resilient designs, which are cornerstones of Zero Outage. Unfortunately, most platform fails from avoidable issues. Some of them are obsolete hardware, which lacks supports and is more likely to fail, and often cannot run modern operating systems, firmwares or patches. Secondly, poor monitoring results in slow reaction times to incidents, or systems may degrade slightly without triggering any alarms. Also, faulty firmware can introduce stability issues or conflicts, especially when mixed with newer software or firmware stacks. For that, Zero Outage recommends the proactive detection and lifecycle management to reduce these risks. A user interface design is not considered as a building block in Zero Outage. While a good user interface design enhances usability, it doesn't influence the system uptime or the fault tolerance, which are the primary cornerstones of Zero Outage. Zero Outage architectures are more concerned with infrastructure layers such as compute, storage, and network. Main reason for hardware changes on a Zero Outage platform are to replace old or faulty hardware, because aging hardware is likely to fail more often and most of the time not able to run newer technologies like firmwares and operating systems. Secondly, end of maintenance support, because when vendors stop supporting a component, most of the time also patches, spare parts, etc. are not available anymore. The third point is closing security issues. Some hardware has known security issues that cannot be fixed with software patches. In those cases, replacement is the only option. These changes should be done proactively and not just in reaction of a failure. There are multiple layers of evaluation, that is bug reports, to identify unresolved or high impact issues. There are threat messages, which provide guidance on known vulnerabilities or threats. It is vendor availability to ensure ongoing support and spare part availability. It is compliance checks to validate alignment with internal and industry standards. And at the end, this evaluation helps prevent instability in production environments and supports change reliability. Staging is a controlled pre-production environment for testing under real-world conditions before going into production. It serves 2 main purposes: training of new IT people without the risk of impacting live systems, and secondly, validating new patches, new configuration, infrastructure changes, etc. to ensure that they all work as expected. With a staging environment, you can reduce the risk of human error, which is one of the most common causes of service outages.